So this is the device for lesson 120's assignment, creating a device that locks out until it's open with an RFID, and then two buttons that can count up and count down, and will lock itself after 5 seconds of inactivity. So I'll run it now. I'm trying to get it so you can see the device as well as the screen. I know the screen's not really in focus, but you'll be able to see it counting, I think. But so I push it and it says C scan to unlock. I'll just unlock it quick, and then I'll just let it sit and show you that it locks again here in 5 seconds. And now I'll unlock it again, and then I'll count. You can see that the count's going up. You can see the LED turns green, it goes up. I'll use the other button, it goes down, and I'll just pause. And there's system lock scan to unlock. If I unlock it, it comes back to the same count it was at before, and I can count. I can let it 1, 2, 3, and then it still works. But if I let it sit for 5 seconds, it locks. So I think that reflects the assignment. So this is the code for lesson 120's project of creating a RFID lock device that relocks after 5 seconds of inactivity, and then just has two buttons to count. So import the necessary libraries. As you can see, I imported timer for a timer for the 5 seconds, and MicroPython because I needed to use the MicroPython schedule function, and I'll explain that down below. Set up the RFID. What I learned trying to do this, originally I couldn't get my RFID to work when I soldered the headers on my Pico W. Apparently I didn't get quite enough solder on pin 19. So it wasn't working with the Mosey pin, so I had to switch it to pin 3. Set up my LED pins, set up my LED objects, set up a counter starting it at 0, and set up a timer. I'm calling it lock timer. I'm using the state machines to monitor the buttons, so set up that logic here. Again, I'm just using one state machine for each button with an interrupt. Set up both the up and down pins and state machines and make them active here. And then here's the three basically basic functions that run the program. So this one is the system lock. It will run here using the MicroPython schedule on startup. I originally had this running with a timer because, as you'll see later, I call this also inside the two down. I call this by a timer, so I needed to have an argument in there, and so I used the timer to start this instead of just calling it, and that didn't work. Well, it worked fine. It's just that once the system was unlocked, because my understanding from Googling is because the timer was a hard IRQ and it was held at the lock screen, Thani started to interpret it as an error state. So actually, after it unlocked, everything that was printed on the terminal after it was unlocked was in red text. So again, a little bit of Googling, I found this MicroPython.schedule method, and it seems to fix that problem and do the same thing. So basically set up the lock timer as global for all the different functions. I basically turn, when I get into the system lock, I turn the up state machine and down state machine IRQ handlers to none, so that if the button's pushed, nothing happens while the program is locked. Turn the green LED off in case it was on before, turn the red LED on, print the system lock scan to unlocked, and then set up badge ID and text for RFID read. I only wanted to print the badge ID, but I was getting the hello world message from the lesson, So I just set up an extra variable and just don't use it. There might be a better way to have done that, but that seems like a pretty simple way to do it. And then initiate the lock timer with a period of 5,000 microseconds. Make it a one-shot timer, and the system lock is what happens when it triggers. So once it's unlocked, turn the red LED off, the green LED on. Just print that the system was unlocked by the badge number and print the count. At that point in time, I set the two state machine IRQ handlers to being active, to having an actually what I do here, is I clear anything that was in the IRQs, because if the buttons were pressed, it wouldn't have done anything here, but those IRQs would have still been locked in the state machines. So I clear those and then turn the IRQ handlers to the two functions up here. So the functions are pretty simple. Again, I have the lock timer so that I can manipulate it, and the count. I de-initiate the lock timer once we get up here, means the button's pressed, so we need to reset the timer, so I de-init it. I increment the count. Here it's up 1, there it's down 1. I print the count and then reset the timer with another 5,000 seconds. So every time through the loop, every time the button's pressed, the timer's reset to 5,000. And then down here, it's just a while true loop to keep the program active. Again, it worked fine without this, but when the system unlocked the first time, I would get this little tilde here because the program didn't have anything to keep running until the interrupts were fired for the button presses. So I just thought this made it look a little cleaner. And then I have the keyboard interrupt to de-initiate the timer, turn off the state machines, and turn off the LEDs so that the program exits cleaner. So I think it turned out okay. There might have been a better way to do this or an easier way to do this, but this was pretty straightforward, and I like using the state machines for the buttons. It seems like it makes the program a lot less cumbersome, and just seems cleaner and frees up other resources in my mind. So again, it was a fun program, and I learned a lot doing it.